Here we have two congruent circles with centers at points O1 and O2. From the point O2, we draw a tangent line to the left circle. It intersects the right circle at point A. We connect point A with point O1. This segment intersects the left circle at point B. And we ask to find measure of this angle, angle O1BC. And point C is point of intersection of these circles. The first thing I noticed when I was solving this problem is that we have several inscribed angles. Notice this angle A is inscribed into the right circle, but angle B is inscribed into the left circle. It becomes more clear if we extend the segment O1B until it intersects the left circle at point D. And now it's actually a good time to remember inscribed angle theorem. The theorem tells us that the measure of this inscribed angle is half of the measure of the central angle that is intercepts the same arc. In our case, the central angle we're talking about is this angle DO1C. This angle intercepts the arc CD, and that's the same arc that is being intercepted by angle B. Sometimes it is easier to find the central angle than to find the inscribed angle, and obviously if you find one of them, we can easily find the other one. But now the question is, how can we find this angle? What we're going to do now, we're going to look at different points. We'll try to connect different points and look at different triangles we're going to generate and see if we can make sense out of it. The first thing, and that seems to be very natural, is to connect point O1 and O2. In this case, if you look at this green triangle here, triangle O1, O2A, we find this is a right triangle, but it is also an isosceles triangle. It is a right triangle. This angle O2 is 90 degrees, and that's because that's a point of intersection of the radius of the left circle and the tangent line to the left circle. That angle should always be 90 degrees. It is an isosceles triangle because the side O1, O2 is the radius, and side O2A is the radius. The angles at the base of an isosceles triangle are congruent. Therefore, they have to be 45 degrees each, because these two angles plus this angle of 90 degrees together should give us 180 degrees. So we are looking for this angle, but we found this angle. So it will be good for this angle if we are able to find the angle right here. To find this angle is actually quite easy. Notice that it seems to be natural if we connect point C and point O2. In this case, if you look at this yellow triangle right here, O1, O2C, we find this is an equilateral triangle. All three sides have a length of radius. Angles in equilateral triangles all equals to 60 degrees. So we find this angle is 60 degrees. And now I pretty much solved the problem. Notice that big angle right here, DO1B, it's a straight line, and this angle is 180 degrees. We know these two angles, which together give us 105 degrees. It means that this angle right here, central angle DO1C, is equal to 180 minus these two angles, and that gives us 75 degrees. But this angle is 75 degrees, that means that this angle right here should be half of it, and that is 37.5 degrees. And we are done. The problem is solved.